Assalamualaikum and hello, I am Hasha with the metric number 1170835. So today, I want to share about an interesting topic which is nuclear science in agriculture. World Nuclear Association stated that about 795 million people around the world suffering from chronic undernourishment from 2014 to 2016 estimated by Food and Agriculture Organization of the United Nations. This crisis can be reduced by the implementation of radioisotopes and radiation in food and agriculture as reported by the FAO. The uses of nuclear technique helps in improving agriculture performance in many ways, such as boost crop production, fight against pests and diseases, food safety and authentication guarantee, boost livestock production, and protect land and water resources. For so many years, FAO has been working together with the International Atomic Energy Agency (IAEA) in acquiring and expanding knowledge in implementing nuclear techniques in agriculture. As a result, the world earns positive impacts from it. For example, in Cameroon, they utilize nuclear technique in reproducing livestock, breeding, artificial insemination, as well as disease control. They cross their two local scatter breeds, which are Bos indicus and Bos taurus, and successfully gain 3 times of milk production. Moreover, farmers in Benin blessed with the increment of milk yield by 50%, in addition reduced the usage of fertilizer up to 70% due to nitrogen fixation facilitation technique. Apart from that, one of the famous nuclear techniques used in the agriculture is SIT, which is nuclear-derived sterile insect technique. SIT is widely used in combating pests, where a mass rearing and sterilized male insects are released over natural population. The insects were sterilized through irradiation of X-ray or gamma ray. This technique represses and gradually eliminates or kills existing pests and also prevents new pest invasion. It is way safer than traditional pesticides. The government of Mexico and United States of America has been utilizing SIT for years to avert and prevent the spread of Mediterranean fruit fly, mayfly, by means of protecting valuable crops such as citrus fruit. Another use of nuclear technology is in food safety. It operates by addressing the issue of harmful residues and contaminants remain in food products, and improving their traceability system by using stable isotope analysis. Last but not least, plant mutation breeding. It is a process that exposes the seed or cutting of a plant to gamma rays radiation to cause mutations. The radiation boosts the natural process of spontaneous genetic mutation, notably reduce the time taken. The irradiated part is then undergone cultivation to generate sprouts. However, only sprout that shows desired traits identified by molecular marker assisted by breeding based on genes is selected and been multiplied. About 3,200 varieties of new crops have been developed through plant mutation breeding. More pest-resistant and harsh climate environment resistant crops have been produced, such as garlic, beans, sorghums, wheat, peppers, and bananas. Let's look at the recent research, which is climate-smart agriculture in Costa Rica. Costa Rica is using nuclear science to help green its pineapple sector. The Joint Food and Agriculture Organization of the United Nations an International Atomic Energy Agency (FAO) and IAEA Division of Nuclear Techniques in Food and Agriculture optimize and strengthens the capacities of member countries in using nuclear and isotopic techniques to improve agricultural resilience and adaptation to climate change. The impact of climate change is assessed to enhance agricultural productivity, better adapt and build agricultural and food security system resilience to climate change impact, and reduce greenhouse gas emissions in agriculture for food security and sustainable agricultural development. What is the objective of this research? Nuclear techniques are used by the government of Costa Rica in order to meet their two main objectives, which are to become zero carbon while remain as world's #1 pineapples producer. In order to have a large number of pineapples production, of course, a huge number of fertilizers is needed. Both IAEA and FAO have supported the Costa Rican experts in exploring the utilization of nuclear energy to help farmers grow crops more efficiently and ecologically. They have come up with a new type of soil additive that can reduce the usage of fertilizers and pesticides, in addition help in lessening the greenhouse gas emissions. Experts from University of Costa Rica's Environmental Pollution Research Center (CICA), together with IAEA and FAO, decided to use biochar, a carbon-rich material from the pineapple residues, as soil additive to enhance the fertility of soil, at the same time reduce the negative effect of chemicals toward the environment. In order to test the advantage of biochar, CICA experts employed a nuclear-derived technique through cooperation project with the IAEA. Pineapple biomass is crushed to synthesize the biochar for farmers to use on the soil. They then plotted the soil by applying the carbon-14 radioactive isotope labeled pesticide. Moreover, this technique allows them to find out whether the biochar aids the soils to store more carbons and reduce the emission of carbon dioxide gas. By doing this, they are able to follow the behavior of pesticide molecules. Fertilizer labeled with a stable nitrogen isotope was used to locate its pathway. By implementing this technique, they want to know if the efficiency of pineapple plants in consuming fertilizer could be increased when planted into soil rich in biochar. A soil scientist at the FAO-IAEA Joint Division of Nuclear Techniques in Food and Agriculture said that isotopic techniques do help in providing essential information regarding the sources and amount of agriculturally derived greenhouse gases. Carbon sequestration. Soil is a mixture of minerals, organic matter, gases, and water. Carbon is a key ingredient of soil and its health, but in the gaseous form of carbon dioxide, it is a greenhouse gas. Plants capture carbon in the form of carbon dioxide from the air, transforming it into organic matters, which boost soil productivity and resilience to harsh climate conditions. The idea of soil capturing and storing atmospheric carbon dioxide, also known as carbon sequestration, can counterbalance the increase of greenhouse gases. Analyzing the carbon-14 isotope allows researchers to evaluate soil quality and source of carbon sequestered in the soil. By measuring carbon sequestration, they can identify whether biochar is enhancing soil fertility and helping reduce carbon dioxide emissions. By using nitrogen-15 stable isotope, we can track the nitrogen amount taken up by plants or lost to the atmosphere, surface, or groundwater and determine the effectiveness of crops taking up the fertilizer. This helps in optimizing fertilizer use on farms. In the future, the experts in CICA hope they can able to achieve a balance where the usage of fertilizer and pesticides could be reduced, in large scale while maintaining and increase the crop's yield, which allow the farmers to earn their living. Another example of the success on the use of nuclear and isotopic techniques for climate-smart agriculture are in Sudan, where the researcher introduced a fertigation system to grow vegetables. The amount of water and nitrogen fertilizer needed by the crops was optimized using nuclear and isotopic techniques. While in Burkina Faso, researchers have determined both the nutritional value of several local available feeds and the nutritional requirements of sheep and goats, and the team developed a program to produce multi-nutrient mineral blocks (MMBF). So that's all a little bit about the nuclear technique used in agriculture. I hope this video can help you to understand about the nuclear technique that used in agriculture in helping the farmers to increase their crop productions. Thank you.